Okay, so this video is going to be over variations. And let's start with the different kind of variations. The first one that we see the most is direct variation. And direct variation is, hold on, this is like seems to be a little bit out of focus, but okay, so direct variation is just going to be, the idea is y varies directly as x. So if I have something like y varies, and you'll see this directly in the problem, directly as x, we would have some value relating y and x, some number k. K is a constant number. Of course, I don't have an exact number for this one because this is just the general formula for it. So this would be a number that relates y and k. So maybe this is a 2 and y is equal to 2 times as much as x. So that's like the relationship between them. You could have that they vary inversely. So this is direct, so inverse variation. The general idea of this one is if y varies inversely as x. So I got to put this here so we know which letters first. It would go y equals the constant value k over x. So this one's like, as one gets bigger, the other gets smaller, or they affect each other inversely, one bigger, one smaller kind of idea. Okay, then they throw in some that are varies directly as the power. Let me see. So these two are the main two, really, that come up. But what if we have a power? So like y varies directly, and it could be inversely as the nth power of x. So y varies directly as the nth power of x. So we start with y, and it varies directly, so you have k times some x, and it's to the nth power. And that's it. So they could add a power on it. It didn't really change the direct variation, right? And if it would have been inverse, this would have been down here. So they can be related inversely as the power of x. So it's just like a larger difference between the two, because then they directly, or they're inversely related or directly related by a power. So it's like a lot bigger difference. You could have a joint variation too. That's just where you times maybe another letter by it, like a y or a q or something like that. Let's look at some examples of variation. You have a couple steps to solve these. You have to find k first if you are not given k. So it's kind of like 3 problems. You find k, then you set up your equation, and then you use your equation. So it's 3 different steps. They're not hard, but for some reason people really forget some of the steps. So what if our problem's if x varies directly as y, comma, and x equals 9 when y equals 3. Find x when y equals 12. Okay, so if x varies directly as y, so there's our formula idea. X equals 9 when y is 3. There's our example that we use to find k. Find, and then we're going to find the actual answer. So again, we have to start with our equation. Y, or x varies directly as y. So x varies directly as y. There's your general formula. First one always goes first that they talk about because it varies directly as y. And directly just meant your constants being times by y. So here's your general formula. Next, you have to find your k. So you put in the 9 and the 3. 9 equals k times 3. solve for k. So you divide 3 over and k is equal to 3. So now we have our k. We can rewrite our formula as x equals 3y. That means they're related by 3. I mean, they're directly related by the number 3. We were given an example that allowed us to find the variation or the constant that relates them. Find x when y is 12. So you put in the 12. So what's x when y is 12? So x is going to equal 36. So notice, formula, find k, use k, right? Right? So let's look at another example. Maybe I didn't even get out another example. That's not so good. Okay, so what if I'm opening a book to steal an example out of it, the harder one. This is page 447. And that is definitely not what's on this page. Okay. What if I had, let's do this one. If z varies inversely as, that wasn't written very well, inversely as w, and z equals 10 when w equals 0.5, find z when w equals 8. Okay, so if z varies inversely as w and z is 10 when w is 0.5, find z when this is when w is 8. So they're related inversely. So z equals k divided by w, right? Because they're inversely related. Now our sample is that z is 10 when w is 0.5. So remember, when you have something like times or divided, you have to times it over. So what's k going to equal? Well, you're going to times the 0.5 by 10. And what is 0.5 times 10, or half of 10, is 5. So k is 5. Now I can set up my formula, right? They're related by 5. And the last part, find z when w equals 8. So w equals 8. So what is z? It's 5/8. We can write the decimal, but that's it. 5/8. So there's inversely. Now you can add squares on these, and that's still the same process. So you're going to run into problems where that you just write the formula, and some of them you have to then find just k, and some of them you have to do all 3 steps, kind of idea. So there's my samples of that section.